AC/DC-Net completes and refines an initial depth map with guidance from sparse SLAM features and an infrared image with projected infrared texture. It obtains state-of-the-art results across both synthetic and real sequences. The video shows that our model predictions are more complete and crisper than state-of-the-art. Our model leverages the interleave mode provided by RGBD cameras such as RealSense, where a texture pattern is projected onto every second frame. We run a visual inertial SLAM system on the frames without the projected pattern, which provide us with accurate 6-degree of freedom poses and 3D landmarks. The active stereo sensor produces a semi-dense initial depth map for the frames with the projected texture. We adapt a channel exchanging architecture as our backbone, which allows the network greater flexibility to use and combine the multimodal input. Our model is trained with a novel photometric loss that relies on both passive and active frames. This is a non-trivial extension compared to previous work and results in stronger signal in textureless areas. Each modality helps the network improve in different regions. The guide image allows the network to exploit context. Sparse features help in faraway regions where the sensor is often noisy and incomplete, and the initial depth helps to fill in details. In this video, we compare AC/DC-Net with a ResNet 18 and a ResNet 50 backbone with state-of-the-art. We see that our model have sharper edges compared to active stereo net. We show that our model predictions are geometrically consistent in 3D and clearly more complete than the initial depth maps from the RealSense sensor, as seen on the wall next to the stairway. Our method runs in real time and obtains state-of-the-art results. Our main contributions are the first depth completion method for active stereo systems, a novel photometric loss for interleave mode, a closely integration with a visual inertial SLAM system, and finally, 2 new datasets for active depth completion and prediction, which will be made available upon acceptance.